All right, we're going to finish out our last example here. We had a tiny bit of technical difficulty in that last video, so we're going to finish this out here. Okay, so in the last two examples, I gave you a height. We substituted them in for y. We got it equal to 0, and then we solved a quadratic equation, usually by quadratic formula, because a lot of these are just kind of a little bit messy to try to factor. All right, so the last one that we're going to look at is how long will the rocket be in the air? Okay. All right, so just as a reminder, this is one of those critical points that we talked about in an earlier video. If we're talking how long is the object in the air or when does it hit the ground, then we're talking specifically about this positive 0 over here, okay? Because the rocket started at a certain height, it went up for a little while, and then it turned around and came back down. Gravity was pulling it down. There are two x-intercepts, okay, but one of them is going to be negative, so we're going to toss that out, and we're going to answer the question of how long is the object in the air or when did the object hit the ground by just giving the positive 0. All right, so here we go. Let's work through this last example here. How long will the rocket be in the air? The one thing that we know for sure is that when it's done being in the air, when it hits the ground, then or the water or whatever it is down below, then the height of the object is going to be 0. So in the place of y, I'm going to substitute 0. 0 equals negative 16x squared plus 64x plus 100. Now in the last two examples, when I substituted in something other than 0 for y, I had to take the time to get it equal to 0, but this one's already equal to 0. So I'm going to go ahead and go over to my calculator and do the discriminant, okay, just like I was doing before. 64 squared minus 4ac, 4 times negative 16 times 100. Okay, so that'll give me a discriminant value of 10,496. And in a minute, I'm going to need to know the square root of that, so I'm going to go ahead and do that while I'm here. The square root of my last answer is 102.45. Okay. All right, so full quadratic formula, x equals the opposite of b plus or minus the square root of, and I have forgotten what that number was, 10,496. 10496 all over 2 times a, negative 32. All right, so x equals, one of them is negative 64 plus, I'm going to go ahead and replace with the decimal. The decimal was 102.45, 102.45, all over negative 32. And the other one is negative 64 minus 102.45, all over negative 32. All right, so let's go to our calculator and get some decimal approximates for those. Okay, negative 64 plus 102.45 divided by negative 32. Okay, negative 1.2. And then the other one is exactly the same. So I used that second enter command to give me my last entry, because all I need to do, I don't need to retype it all in. I can just change that plus to a minus. All right, so one answer is negative 1.2 and the other one is 5.2. Okay, so this one gave me negative 1.2 and this one gave me 5.2. Now the question was, how long will the rocket be in the air? Okay, so does it make sense to say that the rocket will be in the air for negative 1.2 seconds? That doesn't make sense. Okay, what does make sense is 5.2. So back to our graphic organizer for just a minute. Okay, the 5.2 is this one here. This is where it crosses the x-axis on this side. The negative 1.2 is this one over here. We throw that one out for being too negative, or technically really for being negative at all. Okay, so the negative 1.2 is not the answer that we want. The answer that we want for how long will it be in the air is 5.2 seconds.